Today we're going to start looking at definite integration, but we're going to throw u substitution in on it. So remember the definite integration, or the integration from a to b of a function dx. What we're going to do is we're going to integrate that function, so we'll call it capital F of x, and we're going to go from a to b. So then what we're going to do is we're going to plug in our b, plug in our a, and subtract those two values. So we take f of b minus f of a. In example 1, here we're going to take the integration from 1 to 3 of x squared times x to the third plus 1, the quantity, to the fourth, dx. So I could, again, multiply this out if I wanted to take it to the fourth power and then multiply by x squared through, or we could come off to the side and do a little u substitution. U is going to be our x to the third plus 1. Remember, our u is normally that quantity, or the stuff that's in the quantity, or if it's an e, it's going to be the exponent, or if it's a natural log of x, it's going to be the natural log of x. So here, we're going to go ahead and find our derivative. Du is going to equal 3x squared dx. If we come back to our integrand, we have an x squared dx. We can't use that 3, so we're going to divide that 3 back over to the du, and we get 1/3 du equals x squared dx. Coming back to my substitution. Now the thing with this, these values are in x's, in terms of x, and these here values are in terms of x as well. So we're looking at x equals 1 and x equals 3 when we have this. When we change this to u's, we need to also change our boundary points into u's. So we got to change this 1 because it was an x value. So now if x is 1, well, u would have been 1 to the third plus 1, or 2. So we're going to integrate from 2. If I take 3 and plug it in for my x, so then u is going to equal 3 to the third plus 1, or 28. So now our integration becomes from 2 to 28 instead of 1 to 3, because again, we have to change those x values into u values. Looking at my integration now, my 1/3 du is coming in and replace that x squared dx. Then I have my u to the fourth du. I can go ahead and integrate this. U to the fourth integrated is u to the fifth over 5. So we have 1 over 3 times u to the fifth over 5 from 2 to 28. Going ahead and clean that up, we have u to the fifth over 15 from 2 to 28. Now again, I would not ever expect you to know what 28 to the fifth is, but this is going to look like 28 to the fifth over 15 minus 2 to the fifth over 15. And we go ahead and put that into our calculator. So 28 to the fifth divided by 15 minus 2 to the fifth divided by 15. I gotta put that in because I didn't check my math. 28 to the fifth divided by 15. And from that, I'm going to subtract 2 to the fifth divided by 15. And I end up with a nice, very large number. We got 1,147,355 and 733 ten-thousandths. And that would be our area there. Large area, but nonetheless something that we can do. It says we have a calculator. In example 2, we're going to integrate from 1 to 2 of 2 over the square root of x plus 1 dx. Again, we're going to let our u be the more complicated thing, which is going to be the x plus 1. In this case, du is going to equal dx. So I'm going to integrate. Again, I'm going to change my 1 and my 2. These were x values. I'm going to change them into u values. So u was x plus 1. So we plug in our 1 for x. We end up with 2. If I take 2 and plug it in for x, I end up with 3. So my integrand becomes 2 over the square root of u du. I'm going to bring this u square root up. So I'm integrating from 2 to 3 of 2u to the negative 1/2 du. Going ahead and integrating, I can increase my exponent by 1. So 2u to the 1/2 divided by 1/2. Again, we're going from 2 to 3 with this example. 2 divided by 1/2 gives me 4 u to the 1/2 from 2 to 3. I can go ahead and plug in my 3. So I have 4 times 3 to the 1/2 minus plugging in my 2. I get 4 times 2 to the 1/2. Again, I'm going to go to my calculator. So I have 4 times the square root of 3 minus 4 times the square root of 2, which gives me approximately 1.271. And that would be a nice, more smaller answer, a nicer answer than example 1 there. I have one more example for today. So it'll be a quick day on examples. We're going to go integration from 0 to 1 of 2x plus 1 times the quantity x squared plus x plus 3 squared dx. Again, we'll let our u be that quantity, x squared plus x plus 3. du is going to be 2x plus 1 dx. So in this case, we have a nice clean substitution. Our 2x plus 1 dx is going to go out, and our du is going to go in its place. We're going to replace that 0 and 1. If I plug in 0, I get 0 squared plus 0 plus 3, or 3. If I plug in 1, I get 1 squared plus 1 plus 3, or 5, times the integration of u squared du. The integration of u squared is u to the third over 3, and again, we're going from 3 to 5. Plugging in, I have 5 to the third over 3 minus 3 to the third over 3. I can put that into the calculator if you need. 5 to the third should be 125 divided by 3. Then minus 3 to the third, which is 27, divided by 3 gives us 9. So we end up with 32 and 2/3 as our area. And that's integration with substitution. Enjoy integrating.